In this video, we're talking about confidence intervals for means. So here's an example. We survey a class on the number of pets they have, and there it is. We can calculate what we call a sample mean from this. So 2 plus 3 plus 1 plus nothing, all over the total number 5. So we can say that the x bar is 1.2 pets. The question is, how accurate is this mean? Like, we only used 5 people. If somebody just walked into this class and had like 7 pets all of a sudden, then that would change heaps. So we need some idea of how close this is to the true mean. And so we call the population mean. We call that mu, and we're trying to have a good guess at that. This one here we call the sample mean. So we use something called confidence intervals to do that. I'm going to give you this example with Pomeranians. They're a fantastic type of dog. 60 adult Pomeranians are taken, and their sample mean weight is that, 2.21 kilograms. So immediately you might think, okay, this is a bit better because we've got a sample of 60. That's a good start. There's a lot more. And that would have been calculated pretty much just like how we did this sample mean here. You can also do those calculations in stats list, so don't forget how to do that as well. Now, given the population standard deviation is that, we need to find something called a 95% confidence interval. Okay, so we're going to do this by hand. This is probably one of the only times you will ever do this by hand. Here's a formula. It is horrible, really bad, but there it is. So we'll take that formula and we're just literally going to apply it. Yeah, so x bar is the sample mean. So it's 2.21. That's x bar. Take 1.96 times. Now the standard deviation is 0.35 and the n value is 60. And then the right hand side is literally the exact same thing but with a plus. Okay. Now, we can literally just chuck that in the whole calculator and see what we get. 1.96 times, and we'll do a fraction at 0.35 over root 60. Okay, 2.12. And let's do the same thing but with a plus. Conveniently, we can just go and edit the original equation. There we go, 2.30. Okay, now the way that we interpret this is we are 95% confident that the true mean weight of adult Pomeranians is between 2.12 kilograms and 2.30 kilograms. Okay, good stuff. So a few things about this confidence interval. It does not say what the mean is. It just says that it's in this range somewhere. And we're 95% confident that it's in that range. It's very possible that the mean is outside the range, just in case we got like a sample of very light Pomeranians or something. Okay, we want to check this with technology. So we'll do that. We want to go into our stats menu across here. There's an option called inter. Believe it or not, it stands for interval. And we're going to go Z interval. So F1. One sample. And we're going to enter the data as variable. So confidence level is 95%. That's what we're doing before. The standard deviation, I think I said was 0.35. So we're going to enter that. X bar is 2.21. And N is the number, so it's 60. Execute. Oh my goodness. Lower is 2.12, and then the upper is 2.30. So if you had this question, you would just go 2.12 is less than the mean is less than 2.30, like that. One other thing that I do want to point out, this 2.21 is right in the middle. of that confidence interval. 2.21 is right in the middle. And we're sort of going up or down by 0.09 either side. Okay. I'm just going to show you quickly what happens if we do a different confidence level. 90% confidence interval. And we'll just, all we need to do in the calculator is change the confidence level to 90. This is why we tend to not do these confidence intervals by hand, because you see there's a formula for 95, and then the general formula is even worse. I encourage you to think about maybe where that 1.96 comes from. It's to do with Z distributions and inverse normals. But anyway, 90% confidence interval. So there we go, execute. 2.13 to 2.28. Okay, so you will notice that this is narrower. So if we just draw it sort of on like a number line here. So I might go 2.05, 2.10, 2.15, 2.20, 2.25, 2.30. The 95% confidence interval was between 2.12 and 2.30. So it's that red region was our 95% confidence interval. We're 95% sure that the mean is somewhere in that red range. And for the 90% confidence interval, 2.14 to 2.28. So for the blue range, we are 90% confident. I'm hoping that makes sense. Like, if we want to be more sure that we've got the true sample mean in our range, our interval has to be wider so we can catch more possibilities. If we have a 90% confidence interval, it can be narrower because we have to be less sure we've definitely got the mean. Now, I don't know where the mean is. Nobody does, except for those Pomeranians maybe. But the mean could be here, it could be here, it could be here. The mean could be down here. We just don't know. But I do know that I'm 95% sure it's in that red range, and I'm 90% sure that it's in the blue range. Okay, so the other thing that you can do is you can specify how wide you'd like the confidence interval to be. So one thing that I will show you quickly is if I change it so that I didn't have 60 Pomeranians, I had like 10. You'll notice that the interval is like way wider, like heaps wide, 2.02 to 2.39. So if we did like a 90% with 10, you'll notice the confidence interval is super wide. That is because we only have 10 Pomeranians, so we're a lot less sure about what the true mean is. The more Pomeranians you use, the smaller your confidence interval will become. Now, I've also done a dodgy there, because when I changed it to 10 there, I couldn't guarantee that that sample mean would stay the same at 2.21. It would probably be different because we've done a different experiment. So in theory, I could just bump and say I've used like 1,000 Pomeranians and just pretend I did. And then my confidence interval is super duper skinny around sort of the sample mean there. But that is not a valid thing to do, because if you did an experiment with 1,000, your confidence interval might move around because your sample mean's changed. Also, your sample mean X bar is right in the middle of any confidence interval you will ever do. Okay. If we wanted to make sure the 95% confidence interval had a width of no more than, that should say 0.1 kilograms, find out how many Pomeranians we need to survey. So currently, the width is 2.12 to 2.30. So it's 0.18 kilograms wide. So that is the current, or N is 60. We'd like to know how many we need to make it 0.1 kilograms wide. So there's a formula for that. It's this, 2 times 1.96 sigma over W squared. You actually get it from rearranging the confidence interval formula. But we can pretty much just work that out. So let's make sure I've got that formula 100% right. Yes, I do. Let's just plug in everything we've got. So it's 2 times 1.96 times the standard deviation was 0.35. I would love it if the width was 0.1, and I want to square this. So there we go. $188 Pomeranians. Okay, so there we go. Now, we actually need, don't round it down, we need 189 Pomeranians. The reason we need 189 is because 188 will be too wide. 188.2 is just right. But obviously we can't do a survey with 0.2 of a Pomeranian without breaking some ethics violations. And then this is too small. But we want it to be skinnier. They want the width to be no more than 0.1. So too small is good. Okay.